Hello students, let us discuss our next topic, borazole or borazine. In the previous class, we have seen the structure of diborane. Okay, so today let us discuss about preparation, properties and structure of borazole or borazine. So borazole, generally we are having organic chemistry, benzene ring. Okay, so how the benzene ring 6-member ring? In the same way, borazole is also known as inorganic benzene. Okay, so the name borazole was proposed because it is similar to benzene. Borazole we call it as benzene, inorganic benzene, which is similar to benzene. Okay, so this one we call it as. So this borazole is also known as borazole is also known as inorganic benzene, we can say. Okay, so here the systematic name is triborane triamine we are going to say, which is known as borazine. So what is its IUPAC name here? Coming to this IUPAC name is here triborane triamine. So means what here? 3 boron atoms we are having, 3 amine groups we are having. So generally this one we referred as what means the general name is borazine. Okay, so borazole is of isoelectronic structure with benzene we can say, and it is having some of the physical properties which will give similar to benzene. Okay, so this is about borazole. Borazole is also known as inorganic benzene and its IUPAC name is triborane triamine. So this one we call it as borazine. Here this is also known as boron nitrogen compounds. So we call it as this one we call it as boron nitrogen compound we call it as. Okay, so now let us see preparations. So this is about borazole. So now let us see preparation. So in preparations, what we have to prepare here? Borazole we have to prepare. Okay, so first we have to do means this is a first method, we call it as Stokes method here. The first method is Stokes method. Okay, so in this what happens means diborane. So we are taking diborane. 2 moles of diborane is treated with 6 moles of ammonia. Okay, so here what we are taking, diborane is treated with ammonia. So then it will form the compound like here 3BH3 dot NH3 twice. So this is the compound we are getting. So this is the first compound we are getting. After that we are doing decomposition. Decomposition means what? Here we are heating. At which temperature? At 200 degrees centigrade it is heated. So finally we are going to get borazole formula, that is 2B3N3H6 plus 12H2. So what is this component? This component we call it as borazole. So what we have got? Diborane is treated with ammonia. We got this first compound. So this first compound is low. Why? Because we are having polymeric byproducts. So and after decomposition what happening? We are getting a borazole. So this is about first preparation. Coming to second preparation. In the second preparation here, dry powdered ammonium chloride we are taking. It consists of 2 steps. So let us take step 1 here. In the step 1, we are taking ammonium chloride, okay, which is treated with boron trichloride. So means what? This ammonium chloride is heated on a combustion tube at 170 degrees in boron trichloride. So then what will happen? nitrogen is passed over the powder, then we are getting boron trichloro we are getting. Okay, so what we are doing here, we are taking ammonium chloride, next one we are getting boron trichlorate. Okay, so after that, at heating at 170 degrees centigrade, in the first step what happens, we are heated at a combustion tube at 170 degrees centigrade. So with boron trichloride, the vapors and nitrogen will pass over the powder into, it will form 9 HCl molecules, and here forming trichloroborazole. So what we are forming here, trichloroborazole is formed in the first step. So what happened in the first step, see here, ammonium chloride, boron trichloride. So when you are reacting, when you are heating at 173 degrees, the vapors is passing over where, nitrogen. So then it is forming trichloroborazole. See in the step 2 what will happen. So in the step 2 here, trichloroborazole is treated with sodium borohydride, NaBH4. So this one we call it as sodium borohydride. So this is, when it is formed, it will form a needles like crystal. Okay, so when it will be formed, this will form a crystal like, means the needle shape like it is going to form. We will going to get 35%. So here then it is reduced to what, here we are doing reduction, so addition of hydrogens we are doing, and here two types of products is formed. So here two types of products means what it is going to form here, B3 M3H6 is one product, and 3 by 2 B2H6 is one product, and 3 NaCl. So here what we are forming, borazole, this is diboron. Okay, see here first step in the what this is the two steps we are preparing in the second preparation. So what we have taken, ammonium chloride is treated with boron trichloride, it is forming trichloroborazole. So this trichloroborazole is undergoing reduction, which is treated with sodium borohydride to form the borazole diboron. So these are the two byproducts it is forming. So this is about second preparation. Now coming to third preparation. In the third method what we are taking, ammonium chloride and so this is ammonium chloride, next one lithium borohydride, which is undergoing reduction at 230 degrees centigrade. So it will form borazole, lithium chloride plus hydrogen gas is passed. So we are getting borazole. Okay, so these are the three preparations we have been observed now. So what are the preparations of borazole? In the first step what we are doing, we are decomposing with ammonia diboron. So it is giving borazole, which is a less yield. Okay, so in the next step, in the next preparation what we have did, it is undergoing two-step process. In the first step it forms trichloroborazole with ammonium chloride and BCl3. In the second step the trichloroborazole is going reduction with NaBH4 to form byproducts as B3N3H6 and B2H6. In the third step what happens? In the third steps we are taking ammonium chloride, lithium borohydride, which is heated at 230 degrees centigrade. It forms borazole. So these are the preparations of the borazole. Now let us see about properties. In properties, first of all, what we are having? Physical properties. Okay, so what is first one? We are taking physical properties here. So in physical properties, generally borazole, this is a colorless liquid having boiling point 64.5 degrees it is having. Why? Because borazole, benzene is also a liquid. So borazole is also a liquid. So mainly the liquids is going to have boiling points. Okay, so this decomposes slowly even at 80 degrees centigrade. So here these are volatile products. Diboron and other volatile products are formed generally when you do decomposition. So here these are the similarities we are going to have. So means what here? It is having molecular weight same. Borazole is having 80.6 is the molecular weight, melting point, boiling point, and also critical temperature, heat of evaporation. This all it is going to have. Okay, bond distances it is having, density, dipole moment. So these all are similar to the borazone. This is similar to benzene we can say. So what we can say here? It is a colorless liquid having boiling point 64.5 degrees centigrade. Okay, so then what happens here? These are similar to, means density it is having, heat of evaporation, these all properties it is going to have. So these are the most important physical properties we can say. And next one we are having chemical properties. Let us discuss chemical properties. So first one, what is the, up to now we have prepared borazole. Okay, so now we are going to treat with borazole with some compounds, then we are getting the products. So what is the, how we are writing the borazole? So generally it is similar to structure like, so we are having BH double bond N, NH, here BH double bond N, here B, okay, H, and here H. So this is the borazole structure, general structure. So we are taking what here? This borazole. What is the first property? This is treated with 3 moles of HCl. Okay, so when you treated with 3 moles of HCl, observe clearly here, we are breaking the bonds here. Here H will be getting, here Cl. Here one more bond if you break, here H and here Cl. Here if you break bond, H and Cl. So this is the compound we are getting, which means here we are getting cyclic trihalo, means trihalocyclohexane. So this is a hexane ring. So we are getting trihalohexane we are getting. So means what we are getting here? B, H, Cl. Okay, so coming to next, NH, H. Next one here also, here NH, H. Next one B, Cl, H. Next one NH, H. Next one B, Cl, H. So this is the thing we got here, which is known as halogen chloride, trihalogen we have got here. So the derivative of borazole, the chloride, halogen chloride derivative of borazole, it was formed. So after that, what will happen means, when you heat this compound at 52 100 degrees centigrade. So what will happen? There will be loss of molecule like H2. Okay, so there will be H2 will be lost, this H, this H, this H, this H, and here this H is going to lose the molecule. Okay, write Cl here, H here. So whenever it is losing, automatically you are getting here, C, clearly observe, N, B, N. Okay, so now what I have told you here, there will be loss of H2. So here H and here H. So whenever the H2 is losing, we are getting one double bond. Here H is left and here Cl is left. And here also Cl is left. Here one H is left. Double bond we are getting. Why? Because here H and here H it is losing. So next one what here? Here H it is losing, no? So here Cl you are getting, here double bond. So observe clearly, in the borazole we have taken, we have treated with 3HCl. So we got the cyclohexane like structure. So when you heat this first compound, there will be loss of H2. Then you are getting this molecule. So this one we call it as beta B-trichloro borazole we have got. Okay, so this is about first property. So this one already we have got with ammonium chloride, if you have been observed here. Yes or no? Cl3, B3 and 3H6. So same thing we have got with HCl. So now let us see next property here. What is the next property? Next property is also same. We are taking borazole here. BH double bond NH BH double bond NH BH double bond. So means what here? We got here borazole. So this is treated with Br2. Here also we are treating with Br2. So which is treated with 3 Br2, means 6 moles of Br we are going to add here. So then we are going to get structure like B HBr N BRH again B BRH N BRH, here also B HBr N HBr. So this is the molecule we have got here by breaking the double bonds with Br2. So again when you heat this compound, so hexabromocyclotriborazole we have got. What is the compound we have got here? Hexabromocyclotriborazole we have got. So when you treat with again minus, if you here there will be loss of 3HBr. So whenever there is a loss of 3HBr, it is forming as compound like BBr NH B N BBr NH. So means what here? What is the compound we are getting? Again we are getting double bond. HBr we have lost. Here also HBr, here also HBr. So there will be a loss of HBr, minus 3HBr is lost. So we are getting tribromoborazole. Okay, so this is the thing we have got here. These are the two properties we did. So let us see next one. So if you treat with benzene Br2 in the presence of FeBr3, we are getting bromobenzene and HBr is lost. In the similar way, this is also we are getting. Okay, so now let's see next property here. Borazole is treated with B3N3H6. Okay, so this is treated with 9 moles of water. So you are going to get here 3B OH tries plus NH3 plus 3H2. Okay, so means what here? What is the product we are getting? Boric acid. Okay, so this is the product we are getting. So next one, let us see here. Again we are taking borazole. What is the borazole formula? B3N3H6. So what we have did with water molecule, when you treat it, we are getting boric acid and ammonia. There will be loss of H2. So when you do pyrolysis is nothing but what? It will give isomeric products when which undergo heating. That one we call it as pyrolysis. So here the pyrolysis, when you do it pyrolysis, it will form two types of isomeric product. Okay, so one is the product, one is B6N6H10, another one is B5H5N5H8. These two are the products we are getting. Similar to which are diphenyl and naphthalene we are getting. So means what here? What is the diphenyl structure we are getting here? N double bond B, N B, here N B, NH, N double bond B, means H here, H we are getting, B, N, B double bond, here H and H. So here one of the product we are getting what here? B6N6H10. So this is the product we are getting here. When you do pyrolysis, two types of products. One is B6N6 and H10. Another one you are getting. So which is known as biphenyl like structure. This is. So another you are going to get like this. BH double bond N, NH, N, BH double bond NH, B double bond we are getting. Okay, so next one BH double bond NH, NH double bond BH. So this is the product we are getting like naphthalene. Okay, so this is the general formula is B5N5H9. So these are the chemical properties we have did. In the first step what we have did here, we have treated with 3HCl, there will be loss of H2. If you treated with Br2, there will be loss of HBr. In the third property we have treated with H2O, we got ammonia and boric acid. In the fourth step what we had it, borazole, which undergoes pyrolysis at 340 degrees. It forms two types of isomeric products. One is B6N6H10, which is also known as biphenyl-like structure. Another one is B5N5H9, which is like naphthalene structure. So these are the physical properties and chemical properties and preparations of the borazole. In the next class, let us discuss about the structure of the borazole. Okay, so generally we are having here 2,4 diamino borazole is also formed, but when you break down the borazole molecule, it should undergo decomposition of borazole. Okay, so these are hydrogenated products generally we can say. Okay, when we do hydrolysis only, it is going, means addition of hydrogen is going to takes place here. So this is nothing but what here? This is nothing but preparation properties of borazole. In the next class, we can see the structure of the borazole, which is similar to the benzene. Thank you.